Welcome, polar bears and polar cubs. We're into chapter 9. It's one of my favorites. It's stoichiometry. Now, here is what we used to classify as a double roadmap, but now it is a stoic double roadmap. And the big difference is that we added volume here at the top, coming off of mass. And we also have the molar ratio now is based off the coefficients of the balanced chemical equation. A nice little shout out to one of my students who likes to call this mole island. These are the mole islands and how we can connect them. Okay, so you have molar mass, density can connect volume to mass, molar mass connects mass to moles. Moles can be connected to particles by Avogadro's number, and then you can connect mole to mole of the different compounds based off of their coefficients. So just take a look. Density, you can be either given it to you in grams per milliliter or grams per liter. Molar mass is on the periodic table. It is only 2 places past the decimal is what we'll keep it at. And then anytime you see particles, that could mean atoms, ions, molecules, or formula units. So what are the rules? What are the steps kind of to follow for stoichiometry? Well, first and foremost, you got to have a balanced chemical equation. If your chemical equation is not balanced, it makes life pretty much impossible. And then we follow these rules. So we're always going to start with the given written over 1. Then you're going to use your roadmap, your mole islands, to convert to whichever island or rest stop you need to get to. And then you have coefficients to be used as the mole ratio. So let's start. The first part is balancing the chemical equation. Well, this is going to break up into aluminum and oxygen gas. In order to balance this, we put a 3 here and a 2 here. Now your oxygens are balanced, and we need a good old 4 in front of aluminum. It is important that when you are doing stoic work, that you make sure that every single factor has units, labels, and the correct number with it. Notice how the number I said third. All the other ones are just as important as the number. So for this one, we'll start out in grams of aluminum oxide. You're going to write it out as 12.4 grams, Al2O3. We're going to put that over 1. Now we're going to get that 2 moles. So the first step is you want to get it to moles. That's 1 mole of aluminum oxide over the gram molar mass of aluminum oxide. How do you find the gram molar mass? Well, you're going to take the mass of aluminum twice, plus the mass of oxygen thrice, aka 3 times, and you should get 101.96. Now comes our molar ratio. So if you look up at the top, we're going to try to find the moles of aluminum. So we just want to go to Al by itself. And we're coming out of Al2O3. This has a 2 as its coefficient, and this has a 4 as its coefficient. Last but not least, they asked for the mass, so we need to get grams of Al over mole Al. Mole is going to get a 1. This has a molar mass of 26.98 according to the periodic table. What we're going to ask you to do then is I, again, like to have that intermediate step where I multiply all the tops together, multiply all the bottoms together, and then do one division problem. The tops I got in my calculator 133.8.208. I was a little excessive with keeping the numbers. As long as you keep about 4, you should be okay. And then last but not least, the denominators multiplied together is 203.92. Now what we're going to do is make one division problem, and our final answer is going to be 6.56 grams aluminum. Notice how I got my number with the correct number of sig figs, my unit, and my label. All of those were shown throughout the entire mathematical process. All right, we're going to do one more together before I release you to do one on your own. So this one, it asks for the volume of oxygen gas. We're going to use that same balanced chemical equation as the first one. It tells us that we have this as our given. That's the mass of aluminum. So we're going to start out with 9.71 grams of Al over 1. We're going to multiply that to get to moles, so it's 1 mole of Al per 26.98 grams of aluminum. Now comes that molar ratio again. This time on the top, they asked us to get to oxygen. So we'll put O2 up top. And what we have up top right now is Al. So going back to that previous slide, there was a 3 in front of O2, and there was a 4 in front of Al. And then what we do is we have moles of O2 now. So in order to get to grams of O2, you're going to multiply it by the molar mass, which is 32.0 grams O2 over 1 mole of O2. And last but not least, they didn't ask for grams, they asked for volume. So that is where the density of O2 comes in. So we have grams, so grams needs to come on the bottom. And we put liters up top. It is per liter, so that means it's 1 liter. And the grams would be 1.43. Again, strongly recommend that you do this intermediate step. And I'm going to multiply the tops, and I got 932.16. And on the bottom, I got 154.32. Notice how I kept 5 digits there. I know that my final answer, based off of my given right here, should be 3 sig figs. So I divide, and I got 6.04 liters of O2. And there's our final answer. And that would be how you use density within a Stoich problem. All right, we're going to go to the next slide. And this is the one I want you guys to try on your own. So the first thing is you need to balance your chemical equation. I'm going to go ahead and balance that in 3, 2, and 1. I noticed that we need a 2 here and then a 3 here. And we're balanced. Go ahead and try the math problem. You're trying to determine how many grams of ammonia, that's NH3, are produced when 4.37 milliliters of hydrogen reacts with nitrogen gas. They give you the density of hydrogen. 5, 4, 3, 2, and 1. So we're going to start out with the volume of hydrogen gas that they gave us of 4.37 milliliters. That's of H2. It's over 1. We're going to multiply that by its density. So that gives us 8.99 times 10 to the negative 5th grams of H2 over 1.00 milliliters of H2. At this moment, we're on the gram island, and we're going to multiply it by 1 mole of H2 per 2.02 grams of H2. The next step is the molar ratio. So how can we go from one set to another set? Well, up top, we're going to ammonia, so that's a 2 mole NH3. And on the bottom, we're in hydrogen, so the coefficient in front of hydrogen is a 3. That gives us 3 moles H2. Now we're going to go ahead and multiply it to get to grams of ammonia. That's our final step, so that is 17.04 because you have 1 nitrogen and 3 hydrogen. And finally, it's over 1 mole of NH3. Again, like I said, it is very helpful to do the intermediate step. So I multiplied my tops, and I got 1.33887 times 10 to the negative second, and we're going to divide that by 6.06, giving us a final answer with 3 sig figs based from the given. This is in 3 sig figs, so final answer is 3 sig figs, giving us a grand total of 2.21 times 10 to the negative third grams of ammonia. That is your final answer. All right, let me know if you have any questions. If not, go ahead and complete the stoichiometry worksheet and answer the questions on the discussion posts.